Hey, welcome back. Mr. Will here. Happy Friday. This is a video lesson for Friday, May 8th, 2020 for the group Every Day I'm Calculating. And we're back at it. We're working on systems of equations as we solve some real life world problems. So let's check it out. It says Bill and Brandon are downhill mountain biking. Bill starts 500 feet ahead of Brandon and bikes at a rate of 52 feet per second. Brandon bikes at a rate of 50 feet per second. How long will it take for Brandon to catch up to Bill? Okay, so what we can do is we can think about what we know. Okay, Bill and Brandon are biking at different rates. One is biking at 42 feet per second, and the other, Brandon, is biking at 50 feet per second. They start at the same time, but at different locations. What we need to do is we need to find the time that corresponds to the point where they meet. So one starts here, one starts here. They're going at different rates, and at some point, they're going to catch up. And we need to figure out the length of time that it will take for them to meet and be side by side riding down the hill together. Okay? You can think of this as traveling equal distances, but you need to account for the fact that one biker started ahead of the other. So what I would do is I would use a formula for each person, okay? So I would say Brandon, I'm going to start with him. I would say Brandon, Brandon. Sometimes this pen is not very responsive. Brandon, okay, sweet. So Brandon, he's biking at a rate of 50 feet per second. Okay, so I would say 50 times a certain amount of time, t, and they're going to travel a certain distance, d, because remember, one starting here, one starting here, and they're going to meet each other. So that's what we're trying to figure out, the d. Now, Bill, I'm going to change colors for my other one. Bill, we know that he is traveling at 42 feet per second. So what I would do is I would do a very similar equation, 42 times t. But what we need to do is when we make our second equation, we need to take into account that he is starting 500 feet ahead. So we would say d minus 500, okay? Because he's starting a distance of 500 feet ahead, okay? Sweet. Now, looking at these two, could you think about how we could use a strategy that we've talked about before, whether it be a substitution or elimination method to solve these? And what we're going to try to do is we're going to solve for t and for d. How would you do that? So what we can do is we could use the substitution method to solve this. Now, just like our problem yesterday, we're going to have to rework this equation here before we can substitute it into the second equation. Because we want to substitute it here for d, but we need to rework this just a little bit, okay? And put this together as 50t. Okay, so d equals, and we're going to put them together, equals 50t. Okay, we're just going to smush them together. So we would rewrite this as 42t equals, I'm going to put my value for d from my first equation as 50t. Okay, and what that does is it gets rid of my d's, and then we need to do minus 500, okay, because that's what we started. Okay, so what I did there, just so to recap, I took this value, 50t equals d, I plugged it in for my value of d here, and I rewrote my sentence. Now I have two t's, but only one variable, so now I can solve it. Okay, so what I would do is I would subtract 50t, so I have my variables on only one side of the equal sign. So 50 minus 50t cancel each other out. And now I have 42 minus 50t, and that equals 8. So I'm left with 8t. That's an 8, terrible 8. 8t, this pen is struggling today. 8t equals, and that would be 8t minus, that would be, sorry, negative 8t, because I have negative 50. 42 minus negative 50 would be negative 8t equals negative 500, okay? Because we can't forget about that sign with the 500. It's like a leash. We took away the 50, but that negative stays there. So negative 500. Now, how do I get my t by itself? Well, I would divide both sides by negative 8. So I'm going to divide this side by negative 8. I'm going to divide this side by negative 8. Okay? And what that does is it takes care of my 8s. I'm left with t. And then I take negative 500 and I would divide it by 8. Now, you can do your long division. You can punch it into a calculator. But what it would equal is it would equal t equals 62 and a half, or 62.5. Now, we're not quite ready yet, okay? We could figure out our distance, okay, for D by taking this 62.5, coming up here and multiplying it by 50, and that would show you the distance. But that's not what the question asks, so we're going to leave it. What the question asks is, how long will it take for Brandon to catch up to Bill? And the t, the time, is how long. So the answer to this real life problem would be 62.5. It would be in seconds. So 62.5 seconds going down the hill. Brandon, biking at 50 feet per second, will catch up to Bill. How about that? So hopefully this is making a little bit more sense as we take maybe the more abstract idea and put them into the real world application. I want you to be working hard. A majority of what you are going to be doing today is centered around this problem that we just did together. But ask questions, work hard. I'm here to help you, and have a great weekend.